I forgot to hit that live button. Okay, we're live. So we'll just take off from here. So we're doing an overview of the real-time analytics, real-time intelligence module within Microsoft Fabric, creating an overview of real-time intelligence, some of the significance, what real-time intelligence is, the streaming analytics that allows you to be able to do real-time processing of data and create data pipelines within Microsoft Fabric. So that's where we left off. I'll make this full screen. So being able to create, it gives special capabilities to be able to create real-time data pipelines in Microsoft Fabric. The real-time intelligence module does. And these pipelines are very similar to what we've done in class so far, but it just uses its own technologies to be able to process real-time data. So Microsoft has their own proprietary database and language to be able to do that. It has its own streaming service and query tools to be able to process data in real time. And it's similar for the other platforms too. Microsoft Fabric just has their own, which we'll investigate. So real-time intelligence also has ingestion and processing, ability to process real-time data from various sources, specifically for real-time data that we'll cover. So you can implement monitoring and alerting features. So you can take a look at real-time anomalies in the data as they occur, or different situations or thresholds, or create different rules. It's actually fairly customizable what you can do here. And then we'll see the use cases behind some of these. We'll see how this type of monitoring and alerting and real-time processing of data can be used in an enterprise for different reasons, such as optimizing inventory or operations, doing real-time recommendations for customers, and so forth. So it's already there are quite a few applications for it already that we will take a closer look at using some of these technologies. Okay. So introducing it to the real-time intelligence module within Microsoft Fabric. So what is it? It refers to the process of continually inputting and analyzing it immediately to provide insights that can drive timely decisions. It's important in modern business because it helps organizations to respond swiftly to market changes, operations, and enhance customer experiences. There's a little bit different types of data here, but real-time intelligence can handle any one of these, and you'll often use Spark in combination with some of these too. Is that you'll have real-time, you have near real-time data, and then batch processing. So real-time is like streaming in real time. That's like your Netflix video that it's streaming, and then you get you get that stream that's incoming. When you have near real time, it's not quite real time. You'll see an example of this in the demo, but the system will continually update, and then you'll be able to get those observations usually within seconds, or if you do it really well, within milliseconds. So not quite a real-time stream, but it's just about as close as you can get, versus batch processing. So batch processing is when you have a whole bunch of observations that you process at the same time. So that's usually done in traditional methods or with traditional ETL or data factory, but sometimes you'd also use Spark to do that, and you can use real-time intelligence to do batch processing. So So use cases, it includes fraud detection, customer behavior analysis, supply chain optimization, and allowing businesses to make decisions proactively. So I've used a personal example a couple of times in this class. Is I was working at an e-commerce company who has a whole bunch of inventory, and they have people setting prices of new inventory all the time. So one of the people who sets the prices accidentally entered the wrong value for a $100 item, and they put like $1 instead. And by the time it hit the went live on the website, somebody had bought 10 of them at $1. So being able to analyze that in real time and even set an alert to something like that happening is something that real-time intelligence can do. Oftentimes a company will hard code a bunch of these like the hard way, but you could do it by either anomaly detection, or you could create some type of rule. But this is a type of platform that makes analyzing that type of data in near real time a lot easier. So here's a workflow of how real-time intelligence would work. So you're collecting real-time data. It can be any one of those types of data. You process data. So similar to how you do, how we did the modeling or processing for regular data, so not real-time data in the rest of the class, but you calculate, transform, process, and augment, usually augmenting data for your modeling or dashboards or reports. So collecting the data, processing the data, and exploring and visualizing it. They're typical steps, whether you have real-time data or you have more static or once a day or data warehouse type updated data. Okay. So importance in use cases, why is it important? We've said it in a couple times. It allows you to act immediately on insights and events occur. Oftentimes operations teams, they want to know if they can do something in real time because they probably got in trouble for something and they kind of need the data for it. But it can be costly and hard to implement. But a tool like real-time analytics or real-time intelligence helps you do that. So some of the reasons why it's important is like timely decision making. So if you're like me and trade crypto, being able to have information that's updated near real time is to your advantage. Customer experience, talked about that a little bit. Operational efficiency, I brought an example of that up before in my class. So I have a friend, he works at a manufacturing company in Omaha. They use Internet of Things type sensors on machines to be able to tell how the machines are operating in real time. So a lot of this is really to be like as proactive as possible instead of finding out later on that there's some type of issue. Some of it's lots of operational efficiency, so competitive advantage. Uber has a real-time tracking to be able to get to customers before taxis do. And fraud's a big one, so risk mitigation to be able to detect in real time and shut down fraudulent activity as soon as possible. You can tell on your credit cards that banks implement this type of modeling. Scalability and flexibility. So one I didn't think about is that you can attach these to systems or websites and manage the performance of it in real time and the traffic loads in real time. So you can get that information and scale up and down as needed. Internet of Things, supply chain management, like inventory management, and public safety and emergency response. I didn't think of that one either, but the better real-time information you have, the better you can react to certain events or emergencies. So the challenges of real-time data Talked about it earlier in the class. It can be really expensive. Hopefully that a platform like this can reduce some of that expense. And there are additional challenges too, just being able to have that type of infrastructure, be able to process it, being able to manage large amounts of data, and having people who are skilled in real-time data processing and interpretation. Good thing is that these cloud platforms make this easier than ever before. And I think it still takes some data engineering and skilled expertise, but it's starting to get easier and easier. And then there are the use cases that we talked about. So fraud detection, financial monitoring, Internet of Things, e-commerce performance. Okay. So key features of real-time intelligence. So essential capabilities of Microsoft Fabric for effective real-time data handling. So this is the different capabilities that the real-time intelligence module has. So they have real-time monitoring and alerts. We talked about that. Being able to configure these and monitor to notify users of specific conditions. That can be huge in operations, like we talked about. Anomaly detection. That's big in fraud detection, is detecting anomalies in those rare cases, being able to see those. Real-time data transformation and enrichment, having the tools to be able to do that, whether it's Spark, Python, or streaming analytics, or Internet of Things, being able to streaming Internet of Things, their capability for that, to be able to process it, having that available, and then being able to do real-time insights and reporting. So you can use Power BI. They also have some of their own real-time dashboards that we will see. Okay. So the key components of the ecosystem for real-time analytics. So we're using that big picture graphic that we have throughout the class with the different modules and the one lake. So it still uses a little bit of Synapse engineering with Spark that provides the machine learning capabilities and being able to process large data sets, and then Power BI to visualize. But you also have the additions of your data alerting and then your real-time analytics, your real-time intelligence. So you have real-time data ingestion through services like Azure Event Hubs, and IoT hubs. So it has a specific technology to be able to take in and process IoT data. It has event hubs for streaming, processing millions of events per second. And it has Azure Data Explorer and KQL. So this is the proprietary database and query language that I talked about that Azure has. They use KQL, the query language, to interact and analyze data within Azure Data Explorer. It's just a tool they have. And then it gives fast and highly scalable exploration of large data sets. They also have a KQL database. So if this looks very similar to SQL, it has a lot of similarities, but this is just its own language and own database that's used specifically for really near real time and really high volume and traffic data, which relational databases are typically not designed for. And we'll see this, and we'll also see an example of this too. Yeah. So the Fabric's real-time intelligence, the capabilities, I have this image here. You have the different capabilities like event ingestion, real-time analytics, real-time dashboards, real-time AI. Instead of before we turned on the broadcast, has some real-time AI capabilities and decision-making, and you have real-time triggers. So you have event-driven actions and triggers. you can create based on certain criteria. So those are the different capabilities. You have the KQL database that we just talked about, allowing for efficient querying of large data sets in real time. Similar query language to SQL, however, designed for specifically for large real-time data sets. You have event stream, and that facilitates ingestion of streaming data, being able to analyze it as it flows in real time. And you have real-time dashboards and real-time analytics also. So if all of this looks fairly similar to the things that we have done before, I mentioned that data factories, data engineering, creating machine learning model, and visualizing it in Power BI. It is like the exact same process, and you could even do it in the same way and create a real-time machine learning model that does these things and then deploy it. It just gives you, it's an identical process, just using these technologies that are more capable of handling those massive volumes of data or rapid data that's coming at you in real time. So the key components of real time are event sources. These are the different sources where they're coming from, whether it's IoT devices, application logs, business transactions. Maybe those are credit card transactions that you're detecting fraud with, social media or social media feeds, and you can get information about systems. So the event sources are some type of data or some type of source that's producing either real-time or near real-time data. So processing engines, these are optimized for handling that type of data that's coming to you in time, enabling high-performance querying of real-time data. And then the storage solution, so it helps you ensure efficient data management with hot caches for recent data, performance optimization, established retention policies for long-term data handling. So so in a lot of words, it's designed for storing real-time data, and then you could set rules for how you retain it. So real-time processing patterns. So these are the types of different functions or different types of transformations that you would do or rules that you would create on real-time data. And these are available via the real-time analytics, real-time intelligence module. So you have streaming analytics. You use continuous queries and analytics to process data in real time, enabling immediate insights and actions. So maybe you're using KQL to be able to summarize the data as it's coming in. That's often typical. You often aren't storing all of the data in real time. It's just like some subset of the data or some type of summary that you then store within the database for processing. Windows functions. So an operation over time allowing analysis of data streams. So if when you use Tableau and you do like a moving average, that'd be like a type of window function that you could create, especially useful over time series data. You can do aggregations of the data. I talked about that with streaming analytics. Instead of piping in all of the real-time data, you can summarize it as it arrives, make it to get exactly what you need. Pattern detection, detect patterns within the data to anticipate future behaviors and events. You can do anomaly detection. We talked about that with fraud, seeing if there's activity that's way outside of the norm. Data transformation, doing that in real time. In-stream processing, handling it as it arrives. You can enrich the data. It's kind of similar to aggregations or cleaning up the data, but improving its value. Maybe you're applying some business rules to it as it comes in. Change it to various formats, and then you can validate data so you can set up quality rules on it. So quite a bit that you can do with real-time processing. So the process of setting up a real-time pipeline, very similar to what we've done throughout the class. So the objective is setting up the pipeline with the Microsoft Fabric real-time tools, ingesting the data, whether you do that as we've traditionally done with Azure Data Factory, or you do it now with one of the real-time ingestion tools, being able to do that by Event Hub or IoT. So you're getting that, finding a way to handle that incoming flow, and then you're creating the pipeline. So this would be like ingestion would be almost like your extraction or receiving of the data, and then your pipelines, you can do transformations and loads. So like ETL in real time. So first you can use Spark SQL for filtering data. You can also use the KQL query language in that processing engine, but you can filter large data sets in real time that way. That's usually you're filtering, like I said, you're filtering down the real time data sets to be able to get just what you need out of it. You can also aggregate real-time data streams. You'll often summarize them to what you need to be able to view ongoing patterns and trends, visualize in Power BI. Then you can apply machine learning models to them using Spark ML. So in the last class, we used Fabric Data Science, which includes AutoML, which helps you create Spark ML models by notebooks. You can then take those models and then apply them to the real-time data streams. So you can do real-time predictions on the data. This is probably where a REST API comes in most useful, because you're updating the machine learning model in real time and making predictions in real time. And you could have an API. You could have events that come into the API at near real time to be able to predict if maybe a transaction is fraudulent or something like that. So these are probably often deployed by REST APIs, these real-time machine learning services, models that you create as a service. Okay. So there are a number of different alerts that you could create. So somewhat similar to real-time processing. This is more about the processing. This is about the alerts. You can do metric-based alerts, all sorts of different types of alerts. Log-based alerts, looking at anomalies in your system logs, looking for system health. Custom KQL query alerts, so you can create your own queries and really customize your alerts. Conditional alerts, thresholds, time windows. You can see frequencies of alerts. You can create email notifications to be able to alert yourself through email. Very useful if you need to correct an issue immediately. You can set severity levels to alerts, which is really good, because that's always the problem with generating alerts, is that you could generate 1 billion of them, and most of them aren't that important, and then you end up ignoring the most important ones. So making sure you have severity levels on them. Webhooks integration, you can integrate it with Azure Functions, and then logic apps also. Okay. So we're near the end here of the lecture. So this is what kind of a process would look like for setting up real-time analytics. So you'd use KQL query for monitoring the data. The example here is monitoring a system for CPU usage in real time, focusing on like the last 5 minutes. And if it hits a specific threshold, say your server's at 90% capacity, that's when you could create an alert. You could have the query identify that, and then you create an alert. So exactly that, when CPU exceeds the defined threshold, create an alert. Then you can configure alert to specify the conditions under which alerts should be triggered, making sure that you have the most critical ones, like we just talked about. You can set up notifications like SMS, and then you could test alert functionality. So making sure that alerts are working as expected. So you can really see, like, real-time data is almost its own creature. I'd say like a lot of data warehouse data is for analysis purposes. Real-time data is for like anomalies, where you're really typing in data for looking for certain things. I consider it really like a different type of like data analytics or data analysis. It's not like you are forecasting inventory levels based on data warehouse information. This is like really looking at very transactional, very quick data, and then looking for certain conditions and alerting to it. It's almost programmatic, but in a sense, it's like that within operational systems. But it also takes a certain type of analysis. You need to know the systems. You need to know what type of data it's producing, and then what type of alerts are most meaningful to generate. So it takes an analyst to be able to do this too. It's just a little bit different type. Systems analyst, maybe. So the final slide is a demonstration on Fabric real-time intelligence. Well, I frame the challenge here a little bit. So they're using Yellow Taxi real-time data, which is live streaming data for New York City's Yellow Taxi fleet, which is monitored by Taxi and Limo Commission. So they need to know like where all their vehicles are, latitude and longitude at that moment, and which ones are available to pick up, passenger counts, and even like estimated arrival times. This data is transmitted through a REST API. So it's near real-time data, not quite real-time data. So a system would be generating all of these, they'd be getting all sorts of information coming in. And a system would be generating it, and then you'd be displaying, or you'd be able to connect to it at a given point of time, and it'd be near real time. Probably as fast as the taxis could update the data, and the system can process it. So RESTful APIs provide location and status information about the taxis. They allow the developers to retrieve and update on taxi availability, location, and other things. There are multiple applications and platforms that need this system, like ride-hailing apps like your Ubers and taxi dispatch systems. So this one ends up being a pretty technical demo that he gives, but he does a really nice job here of showing the different components from start to finish. So it's first setting up the data stream and then processing the data using KQL and then visualizing it in Power BI. It's about a 25-minute demo, so I can let everybody view that on their own time, how you'd like to do it, however you'd like to do it, and use your time today. I'll pull out the link for this video. Oh, if I can. I'll do that here in a minute. Okay. So additional resources, Microsoft Fabric documentation. As always, the Microsoft Learn. Be able to go there and learn more about real-time intelligence. I personally like using AI and then just a bunch of example videos. That works too, but I go to this. It gives a really nice guided. Microsoft does a nice job of providing really nice guided walkthroughs of how to use their different technologies. You have KQL query reference. This language is a little bit different than it's a query language and it has its similarities, but they're very much things that are different about it than SQL, just by the practicality of what you need to be able to do with real-time data. Window function would be one of those and how it's done. But you can see those type of references on the internet, and then just any types of sample templates within Microsoft Fabric you can use. It has a few of them. I briefly mentioned that as we've gone through the modules, but within Microsoft Fabric, I started to do one today. If you go to even this, they have samples. If you're in data science, you can do models, get started with experiments. But if you're in real-time intelligence, I was just looking at one of these today. They have a various real-time intelligence samples. You can get started with KQL, get started with real-time intelligence. Which one I was looking at. If I hit open, hopefully it will open. Be patient with it. So one thing I didn't mention is part of the database in the lecture. Of course, it breaks on me. Is that part of the real-time database and the processing? It creates what's called an event house. So instead of like your data lake house, it's a lake house type storage specifically for like log data and real-time data. So the KQL database does that. And then there are also capabilities to create a real-time lake house, like real-time data lake. And this is what it looked like. So you can see, you can set up databases and tables for streams in a similar way, create functions, track data, and so forth. But there is an example here. Explore a sample. Maybe I should do that one instead. Oh, here you go. There's stock analysis. That's the one I started to take a look at. You can do this and it'll connect to a stock market service of S&P 500 stocks. And then you could see the workflow in real time. So lots of these examples within Fabric. That is one of the good things about Fabric, is at least you can build from the start, but it gives you some breadcrumbs or examples of how to get started. So that's loading up. And then you could do weather, or you could do an IoT example. And then you could pick apart how it's put together and then put your example together in a similar way. And I just briefly looked at this, but here's your KQL query. This is how it looks. Instead of like a select, you say data set and then pipe count, where you can summarize your data sets in certain ways. So it is different than SQL, quite a bit different query language. but primarily for really processing like this real-time close or near real-time data. That's hard for traditional databases to do. So a lot of this you could probably also do using Spark and being able to process data that way. If it gets to be big enough, the data set, then this might be your only option. That's oftentimes why it becomes so expensive in an enterprise. It's just the processing power or the technology that's needed to do things in real time, which the cloud helps out with. All right. So that's it for real time. I'm going to try to get this link. Insert. I'll take a look at this in just a little bit after we end the stream. So one other thing I wanted to share with everyone is that I also dropped in a lecture with additional resources and readings. So I didn't update this a whole lot from the last class where we covered Microsoft Azure, but it does have a location with some lectures. There's these slides and some of the lectures. You can always go back into the Slack channel to get those too, but it has some links for that. Some videos on how to use different things within Azure. So you have very similar technologies within Fabric, like the machine learning lab that's within Azure. It's pretty similar to the data data science module in Fabric. What did we cover in class? So in this class, so there's a lot that we didn't cover. There's just no way that you could. That's why I like the idea of going with Microsoft Fabric, is that it's really like they're trying to, I get what Microsoft is doing. They're really trying to narrow it down to exactly what data scientists and data engineers need, that collaborative platform. And while it's missing some things, there is an entire like Azure platform up there that I've mentioned a few times in class with various relational databases, big data technologies such as Hadoop and Cosmos DB, NoSQL. It's kind of like, and then like Databricks, which is like kind of like Data IQ in the sense that it's like a really nicely integrated environment for machine learning and teams, kind of similar to Machine Learning Lab is. And then they have all sorts of administrative tools in here, like role-based security, data redundancy and recovery, and so forth. So there is a whole world outside of Microsoft Fabric that we didn't cover, but we cover a lot of ground in this class and try to focus on data engineering and data science and cloud computing and REST APIs in the context of cloud computing and everything within the context of data engineering and data science. But there's some additional topics if you want. There's also another certification test. It's like Azure Data Engineer. I think it's like a DP 300, and it's extremely difficult test. It's a serious like engineering and administrator test. If you're ever interested in that. Microsoft Fabric. I presented it in the last class. We learned all about it this time. But yeah, we did a pretty thorough job. We pretty thoroughly covered Microsoft Fabric in this class and all the modules and capabilities. And then certifications exams. The 203 is the Azure Data Engineer. associate. So this is like standing up and maintaining serverless databases and storage and scaling it up. That's like what that data engineer is all about. It's like really like an administration, like data engineer and administration job. There's also data fundamentals. This is probably a little more like working with data. There's also a Power BI one that you could take. Some more about like data analyst work using Microsoft Azure technologies, maybe it's SQL technologies, using Transform or Power Query within Power BI and so forth. This is probably one that a lot of people would look at. And then DP600 is someone I've given a couple questions on. So Microsoft Fabric Data Engineer. And then a couple different links down here. There's some exam prep. And then there's always a question about how do you get, your first data engineering job and what certification should I get? I think certifications will help in the sense that it shows your expertise. That's why I'm working myself on Fabric and like data engineering certificates as a consultant, is because it shows like I have expertise in something specific. It shows a client that. And in an interview, it can show if you go to a company that uses these type of technologies, it can show like, yeah, I have the knowledge to be able to do this. I think it's like a little bit of a step ahead within a job, but it doesn't guarantee you a job just because you have one of these certificates. So what I actually, there are these videos, is it worth your time and what will you learn? What I just recommend to people is there are all sorts of opportunities for people in data within organizations. Is that just go somewhere and then just start doing little things and volunteering to do different things within the organization. So if you start, I've always picked on Melinda throughout the class, but just start by helping, even if it's small in their organization, helping gather and put data together. You'll eventually want more and more data and more analysis. They'll be like, oh, this is great. How do we get more of this and more reports and dashboards and so forth? And then you'll be able to like put some of these engineering skills in place. And perhaps even at some point, you'll be able to make the recommendation and say, hey, there's a whole platform that helps us manage these things. We could do it so much better. And it'd be up to them to listen. They don't always listen to me, but you can at least like make that recommendation, or then you have the skill, or you could go somewhere. Bigger companies often have like Microsoft Azure, AWS platforms. It'd be similar technologies with AWS. You're just learning the details of a different platform. So hopefully, if nothing else, this class has provided a basis for that, and you could just keep working with data. That's how I did it. And then after taking air lumps and bruises over 17 years, you figure out better ways of doing things. But you get a head start. You already know some of the better ways of doing things. So glad to help everyone with that. It's probably a good wrap for the class. Here the lectures are there. Is there anything, comments, or anything anybody like to add? Questions? I went through everything pretty fast.
I mean, I just agree with you on the like how to get started in career stuff, because that's exactly how I got into data world as well. I was a production scheduler actually at a college. I got a supply chain degree, And then that requires knowing how to do some data stuff, just like looking at numbers and deciding schedules, right? So then they started doing more and more and more, and eventually moved me into a full-time role doing data analytics. So
Yeah, Melinda just got a job, full-time job too. She signed up for an internship, and they're like, we love her. I think that's how it probably went, right, Melinda?
I guess kind of. I mean, Nate put me in touch with them after I finished my BI certification, and yeah, pretty quickly they decided to put me on full time. There's not a lot of data work right now. It is just a lot of like reworking stuff, which is a little bit annoying, but like it has to be done. But it's about to be end of year, so when I kind of come back from holiday, it'll be like end of year reports and stuff. So I'll finally be able to do some of the things that I want to do. But yeah.
Yeah, just like even Skylar, if you go somewhere and you're a systems operator, you'll know all about the systems and the processes and the data, and then generate some reports and get you started. Just getting started doing it somehow. You find that it becomes your full-time job. When I worked at West Corporation in the call center, that's what got you to like a team lead or a manager. You're pretty much pumping out data and doing reports at that point for the team, for the management above you. If somebody started they'd volunteer for it, right? They'd like know the processes and call types and schedule and everything. And then they just start putting together reports and get promoted that way. And then it never ends. That's what I found. I had no idea what I was getting into when I got started. Started as like a financial analyst with computer science background skills, a master's degree in statistics. But basically just like I went and started to get familiar with finance and business operations and systems and everything. And then you become valuable. You start to become that go-to person. And then they start asking you crazy stuff that now you have hopefully have some of the technological skills, or there's a solution maybe you could see, and whether it's Fabric or creating it in Python or whatever platform it might be. Whatever you have in front of you. Python's always a good start too, or a relational database, getting it in there, being able to produce data and reports that way. This class particularly focuses on engineering, so engineering becomes more and more important as either the data really grows or you have special cases like real-time data, or you need like some type of real-time data prediction, or you need some type of specialized like storage to process data. Those jobs are fairly rare, I think. They're your big data jobs. Most everything is done within like a relational database, like a transactional database or data warehouse environment at companies, usually, if you have data warehouse, or it's a bunch of Excel sheets or something. But it's not like part of there. Eventually you'll be asked about real-time data, and you have to be realistic about it, but you can always try to make that case or persuade someone. You're in the position to do that. You get to see a lot when you're working with data about operations and business and the way people are doing things. It's an interesting place to be. And engineering is just all about using like your data development skills to be able to manage data and process data in a much more effective manner, especially at scale, and create models and help deploy those and manage them. The data management is never really done. It's always constant. That's the thing. People don't even know about. Like you're producing 1 million reports and somebody's got to go manage all that data, manage all those reports. It's not just a blank slate, really. And that's why I personally try to think forward and automate as much as possible, which you can do through pipelines. You can do some through pipelines. Just initially do a lot through Python. You can create like pipeline type steps there. You can extract data, transform it using pandas, and then load it somewhere else. But even then, eventually, if you have 100 Python pipelines and one of your business rules change, you're like, oh man, where are all the pipelines where like I need to go apply this? I need to go apply this new rule. Really difficult, becomes difficult to manage. So it's all about managing at scale. If you start small, you don't need it quite as much. Start with Python, and then you could migrate it later. If you're doing real time, if you're deploying to a REST API, Skylar, that's where some of these tools also come in valuable. Is it so that you don't have to, you can write all of that code, and with the large language models, it becomes a lot easier. What I found is the hardest part is all the configuration, setup and configuration. It takes forever. And then somebody has to manage it too. So that's where there's a big advantage to cloud platforms. That's why the other day I said I'd probably just let your IT team do it. Have someone there manage it. Otherwise, you'll be stuck with it, managing it. I've had that happen to me too. It's like, oh, it's yours, especially at smaller businesses. It's like, oh, it's yours now. There's nobody else here to do it, or nobody else wants it. Been through a lot. But I'm glad to share what I believe is knowledge and wisdom with you. Like teaching the class, and hopefully you got some good value out of it. That is it for the class. I'll end the stream and I'll just keep it going for homework or project questions while people to work. So Professor Jeremy signing off for this version of Cloud Solutions and API integrations. It's been a pleasure teaching everyone here in Omaha Data Science Academy.